তো কামিং ব্যাক আমরা ছিলাম কোথায় নোমেনক্লেচারে নোমেনক্লেচার আমি কিভাবে বললাম যে different hetero atom for oxygen, nitrogen, sulfur and phosphorus there have been some prefix like oxa, aza, thia and phosphor. And similarly, whenever the ring member is 3 member, 4 member or 5 member or 6 member, then with ring with nitrogen that have a different suffix. Without nitrogen there are also different suffix, and these are the tabulated form here, and it can be applied for this. This in for this one. This is 4 member ring and it is saturated and it is contain the heteroatom oxygen, so it is non-nitrogen without nitrogen. So first of all, 4 member ring oxygen's prefix is the oxa, so oxa is come, and it is 4 member ring without nitrogen and it is saturated, so ethane is the suffix, so oxa plus ethane, so it is oxatine. This is the naming of this compound is the oxatine. So in this way we can easily naming the different heterocyclic compound by using this table, where we can use the different suffix for the different type of member ring like 3 member, 4 member, 5 member, 6 member and 7 member, and also be that member say this heterocyclic compound also divided into 2 class. It is that ring with nitrogen and ring without nitrogen, ring with nitrogen and ring without nitrogen. There are also heterocyclic aromatic compound, 5 member aromatic compound. This is pyrrole, furan and thiophene. This is a very important 5 member aromatic compound, and also there have been benzo-fused compound. This is the indole, benzo-fused aromatic 5 member ring. This is the indole compound also. There are also 6 member compound. In this 6 member compound, that is the pyridine, pyrimidine and pyrazine, and also quinonyl, isoquinonyl. That is the benzo-fused 6 member heterocyclic compound. There is then one benzene ring is fused at the position, so it is known as an benzo-fused 6 member heterocyclic compound. Benzo-fused 5 member aromatic compound, that is the indole, and benzo-fused 6 member heterocyclic compound, that is the quinonyl and isoquinonyl. And only the 6 member compound is the pyridine. That are the very important compound and also discussed in your syllabus. Now the numbering started for this heterocyclic is the clockwise and this anti-clockwise. There when numbering started from the heteroatom does not contain any pi bomb, and towards the direction of the heteroatom get the lower positions always. So indole system first 5 member and then 6 member being this naphthalene system is likely also. And here there are some properties of this heterocyclic compound. Whenever you can compare the 5 member heterocyclic compound, these are the 5 member heterocyclic compound, which is the furan, pyrrole and thiophene. These are the important 3 5 member heterocyclic compound, and there if we consider their aromatic character, then pyrrole, furan and thiophene are aromatic, because what happened, this aromatic means it has the lone pair, and these lone pair involved in the conjugation, so it is 2 pi electron, this is 2 pi electron and this is 2 pi electron, so it is 6 pi electron. This is the 6 pi electron. So whenever you can consider a furan, it is a 6 pi electron, and 6 pi electron means it is an 4n plus 2 pi electron containing molecule in cyclic, and is all the carbon as the sp2 hybridized. So it is an aromatic compound. So it is an aromatic compound. Then pyrrole also, similarly pyrrole also a aromatic compound. Thiophene, that also an aromatic compound. But the resonance energy for this different compound is different. That means the highest resonance energy for the thiophene, and after this pyrrole and after the furan. Why this thing is happen? Because whenever you can consider the 5 member ring, see this is the orbital picture of this 5 member ring, and for this furan, this lone pair, electron pair or p electron pair, this is very much parallel, and this is one, and this electron and is the sp2 orbital perpendicular to this p orbital. Whereas for this pyrrole bond what happened, this electron is then p orbital and this hydrogen is that hydrogen and hydrogen. Now why the resonance energy for this pyrrole is the higher than the furan and thiophene is the maximum? If we consider the electronegativity of this heteroatom, then which atom is the lower electronegativity? The thiophene is the lower electronegativity. And whenever any molecule has the lower electronegativity, then they have a tendency to donate their electron pair. They donate their electron pair towards the ring and make this molecule is the conjugated. And here, as the electronegativity gradually So electronegativity gradually decreases. As the electronegativity gradually decreases, then what happens? Electronegativity decreases means lone pair availability for the conjugation is increases. As the lone pair availability for the conjugation is increases, then the aromatic character increases. Now, this is the order, aromatic order. Is the benzene is the highest aromatic, after that thiophene, and after the phenol, and after that furan. So why this aromatic resonance? Because we already mentioned their resonance energy is the highest for this thiophene, after that phenol, and after that furan. So thiophene is the higher resonance energy because thiophene has the lower electronegativity, so it can easily donate that electron pair towards the ring carbon. Whereas the nitrogen and oxygen atom, that is the highly electronegative atom, so they can have an attraction for this lone pair electron is high, so they are not easily donated for the conjugation. There have been resonance structure and canonical form for the different heteroatom 5-member heteroatom cycle. There is the furan, second one is the thiophene, and third one is the this pyrrole. So if we consider and this heteroatom as in 1, and this is 2, 3, 4, and 5, then see whenever you can drawing the conjugate canonical form of this furan, we always get a negative charge. We always get a negative charge at the positions of this 2, and this is 3, and as well as 4, and there is the 6 positions. So, but that here also thiophene also getting the negative charge on this 5-member heterocyclic ring, and for this furan also, a pyrrole also, the nitrogen atom is this nitrogen atom can donate their electron pair for this conjugation, and it have a negative charge at all the positions. So the conclusion is that they tend to, whenever you can any position get a negative charge, so obviously electrophile will be attacked there. Electrophile will be attacked there because of this negative charge, and that's why what happens whenever you can consider the electrophilic substitution reaction. Whenever you can consider a substitution reaction, then electrophilic substitution reaction, due to appearance of the negative charge on this carbon atom due to the delocalization agent, so it is canonical form, it is getting the trivialized carbo, and that's why the electrophile will be easily attacked at this position, and these substitutes are easily bound towards the aromatic electrophilic substitution reaction. So electrophilic substitution reaction, there are different electrophilic substitution reaction for different heteroatom like oxygen, sulfur, and nitrogen, and different alpha substitution. If this position is the with respect to heteroatom is the 2 position, that is the alpha substitution, and whenever this with respect to oxygen atom, it is that 3 or 4 position, that is the beta position. Whenever it is 3 position, it is with respect to oxygen, it is the 3 position, that is the beta positions. This is the beta position. When these positions are occupied, then beta position will be substituted. Whenever the alpha position is already occupied, then what happens? The substitution will be occurred at the beta position. Here we show why the beta position is stabilized the intermediate, because whenever the beta, this is alpha substitution, whenever the alpha substitution is happening, that is the 3 canonical structure, and whenever you go into this 2 canonical form, and that is the 2 canonical form has the lower energy as compared to the 3 canonical form energy. That's why the 3 canonical form are the most stable, and that's why alpha position is the very much bound towards the electrophilic substitution. The alpha position is the very much bound towards the electrophilic substitution. So order of the reactivity is the pyrrole is first, after the furan, and after the thiophene, and last is the benzene. Benzene is the more here the order of the reactivity order, electrophilic substitution reactivity order. So benzene is the lower activity, and pyrrole is the higher activity after that furan, and after that thiophene also. After that furan and after that thiophene also. So when these positions are occupied, the beta positions is substituted, and when these positions are occupied by the beta position is substituted, and the order of the reactivity is the pyrrole is the highest, after that furan, after that thiophene, and after that benzene. That is the order for the reactivity order for the for the electrophilic substitution reaction of this aromatic 5-member heterocyclic ring. If the substitution occurred at the alpha position, then it only generates 3 canonical form, so it is very stable. And whenever you can consider the different beta positions, then what happen? We already get the two canonical form, and that's why two resonance form, the two resonating structure or canonical form. That's why the energy required for this beta positions they have a very low energy. Now, why the pyrrole and pyrrole is because the electronegativity and orbital overlap. Whenever you can consider the electronegativity, obviously thiophene is the more electron donating atom. So it would be highly activated. But with respect to electronegativity order, there are also another things, that is the orbital overlapping. That is the orbital overlapping. Whenever the orbital can overlap, then only they can matches, and they showing the alpha or beta substitution. There have been another point for this physical property of this compound is the dipole movement. What is the dipole movement? Dipole movement has two types of movement. One is the sigma movement, another is the pi movement. Sigma movement is always doing by the single bond, sigma bond, and pi bond is present whenever the compound contain any double bond or triple bond character, then it contains the pi bond, and this pi movement is there. Here I am showing that all the 5 members have aromatic compound and their sigma movement as well as the pi movement, and easily the sigma movement and pi movement reinforce each other, and it shows the higher dipole movement for this compound. Here the exceptional is the pyrrole. Pyrrole exceptional. Why? The pyrrole has the nitrogen bond, and where the sigma bond and pi bond are acting in the opposite direction. Both sigma bond and pi bond are acting in the opposite direction, whereas for the other compound, furan and other compound, there is the both sigma movement and pi movement occur in the same side, so it is reinforced each other, except this pyrrole compound, where what happened that the sigma movement and this pi movement are work oppositely, and as a result one reduced to another, and this compound is getting less. The dipole moment will be less, and that's the problem. The dipole moment of the pyrrole and pyridine act as an opposite direction. Explain why. Because pyrrole and pyridine difference is that pyrrole has nitrogen-hydrogen bond, and these nitrogen-hydrogen bonds have a dipole moment direction towards the hydrogen to nitrogen, and as a result that is not reinforced to each other, and this nitrogen dipole moment value gradually decreases. Now, aromatic substitution reaction for the furan compound. Furan compound, they are very much prone. I already mentioned they are very much prone towards the aromatic electrophilic substitution reaction. Aromatic electrophilic substitution reaction. Among these aromatic electrophilic substitution reaction, there is the alkylation and acylation. There have been sulfonation. There have been nitration. Different kind of reaction is there. So most important is the nitration reaction. Nitration reaction occurs in presence of mixed acid, which is the concentrated nitric acid and concentrated sulfuric acid. This is the concentrated nitric acid and concentrated sulfuric acid is generated into O+. This nitronium ion, ethanoic nitronium ion, can easily substitute the proton by hydrogen at the alpha position. Then it can be formed immediately the alpha substituted nitrofuran, and similarly sulfur trioxide in pyridine, or only sulfuric acid that can generate sulfoxide, SO3H group in the alpha position. There are also acetic anhydride and BF3. BF3 is the Lewis acid, acetic anhydride BF3, and that doing the acylation at the furaning, acylation in the furaning, and give the acylated furan product. It gives the acylated furan product, and there have been two types of things. See, whenever acetic anhydride in the phosphoric acid room temperature is there, their form is the two type of product is formed, and the ratio of these two type of form is the 2:1. So alpha position is the more reactive than these other positions, and this is the another thing. Whenever the bond is already the alpha position, true alpha position was blocked by the blocked by the methyl group, then the then the acidic anhydride and essential will be blocked, will be attacked at this position where it has the lower stereochemistry, and as a result it can be attacked at the position of this 3 or 4 position, and this position the acetyl group is the introduced into the furanic. In such way we can easily introduce the Philip reaction, and after the different kind of work for this Uren function. Halogenation reaction. There have been furan can be halogenated at the alpha position. I already mentioned. For the electrophilic substitution reaction, there were always the substitution reaction occur at the alpha positions, and this furan that can be alpha substituted at the alpha positions whenever you can use the pair to an H pair. There are furan also substituted by their different kind of substituted product. Then first furan transform into mercury chloride and a mercurous chloride furan complex, and this can be oxidized in presence of iodine, and this is the iodofuran. This is from the iodofuran. There are another type of reaction, that is the nitration reaction. Nitration reaction can done with the mixed acid or concentrated nitric acid by H2SO4. In such a way, there are different kind of reagent used for the hydrogenation of the nitration of the 5-member heterocyclic ring. So this nitration process is done with the mixed acid like concentrated nitric acid and concentrated sulfuric acid. And there are also another thing is that NO2 plus BF4 minus and in ether. And there was acetyl nitrate in acetic anhydride. Acetyl nitrate in acetyl anhydride. Also, there have been some specific reagents. These are the N2O5 and dilute nitric acid. N2O5 and dilute nitric acid. So generally, what happens? Generally, this acetic anhydride nitrate and acetic anhydride and acetic nitrate, and at 5 degree temperature, that is immediately substituted the proton at the side by side of this furan ring, oxygen ring, and it can form a 2-nitro furan type of compound. So, but most of these cases, we are generally discuss two type of reagent. One is that NO2 plus, NO plus BF4 minus, and this the acetic acetic nitrate in the acetic anhydride. This acetic anhydride has very much effect towards the acetylation reaction. That's why this always preferred through acetylation reaction at the heterocyclic molecule, and here heterocyclic is the nitrogen. So for the furan and pyrrole with not strong mixed acid is used. For the furan and pyrrole, I already mentioned strong acid or base is not required or not touches with this base like nitric acid. So what happened whenever furan and pyridine is substituted with this proton, only proton, then there have a ring junction. Ring junction means ring opening is happen in this ring structure, and this conjugated with this H plus ion, and after that it can be form a dimerized form. It can form a dimerized form. This is the CH3I, and as a result there have also CH3I. So this is the different position when the furan ring is substituted with the oxygen and other thing that can be easily substituted by the other ring at the 2 or 4 position. Now, in the phase of furan, in the case of this acid, this type of acid, there were no polymerization or dimerization thing is occur. Only no reaction is the dicarbonyl compound. No reaction is occur. So conclusion: strong acid medium should be avoided for the furan and pyrrole. For the strong acidic medium should be avoided for the furan and pyrrole molecule also. So this furan molecule, there are two type of behavior. One is the aromatic nucleophile, other is the diene, and other the enol ether. One is the aromatic nomenclature, another is the furan, and third one is the enolate ether. Enolate ether is the different kind of thing. So this furan, this furan, what happened? This furan can have two type of thing. One is the diene. This oxygen and thing is the one is the diene and one is the enol ether. One is the enol ether. Enol thing is there and ether also there, and there are also two things that diene of this molecule. Now, what happened if furan is treated with the concentrated acid? Whenever you can treat it with the concentrated acid, then what happened? Then immediately this compound is transformed into the elevated compound. Elevated compound is the another thing where the nitrogen of this the concentrate term, this the max acid is mixed acid is the mixed with the aromatic compound. Then you can get the aromatic compound. What is the mechanism? Mechanism with the furan is the furan compound can be oxygen is the lone pair, and these contain lone pair. That's why it can be easily and other things, which is the basically source of proton, and ring juncture is occur. Ring juncture is occur for this process. That's why we always used the for nitrogen reaction or furan type of reaction, and in the presence of the other people, because it is difficult to draw the first time different mechanism, and where carbocation is generated, this carbocation and will be replaced by the OH group, and this OH group this compound is good with this mechanism is showing that easily. This is the difference between the 1,4-furan and 1,1,furan, and this is the pyrrole. This is the case of this pyrrole, that is a two structure. Another thing for the furan, that is the different structure and different type of molecules happen. So now, for example, if we have a formaldehyde or acetic acid in HBr, then what happened? We have an acetic acid, and there have an acetic acid, there have an 7 to 100 degrees Celsius HBr, acetic acid and HBr. Then what happened? Then immediately this link is open, and the reaction is going to in such a way that ring opening reaction is happening. Ring opening reaction is really happen. So ring resonance is happen, and it keep the dione compound. It give the dione compound. So similarly, for this different type of reaction for this furan, it is the N2BF4 minus. N2BF4 minus, it give the nitrate product at the ortho position. There have been acetyl nitrate and acetic anhydride that give the nitrate product at the ortho position, or it's also alpha position of the nitrogen agent. And this alpha, whenever you can consider the alpha position, alpha position is substituted with this alpha position is substituted by the electrophile, and this electrophile this electrophile will be react with the react with this electrophilic substitution reaction, and it see that it is forming a unsaturated. It form a unsaturated 5-member ring, and there have an electrophile in this normal way. It can give loses is proton, and the normal example NH and NR2 but S, that will be from the saturated unsaturated compound. This is the from the unsaturated compound. There have been nitration of this heterocyclic nucleus. Heterocyclic nucleus nitration reaction is acetyl nitrite and acetic acid is done, and then you can get maximum ortho product, and some material amount of the meta product will be obtained. And then how to prepare this compound? How to prepare this compound? If we want to prepare this compound, then first of all we have to block the position for this for the starting compound to their nitrate compound. This nitrate compound, and after that what happened? There should be the major product, and there also be minor product. So major product, first of all, this compound can be reacted with the base, and then this remove their hydrogen atom, and by the protonations and proton, and after that setting this nitrate product. See here what happened, that's only the meta product will be obtained. So ortho position or this nitrogen containing compound that contain a sulfur containing isopropyl group, and this sulfur containing isopropyl group or this isopropyl group for the 4 different atoms. There is the chiral center and the there is this critical core temperature. Whenever this reaction is going on, then what happens? That we are only getting the 3-member nitrogen compound, 3-member nitrogen containing compound at the 3-member position with respect to. So this is the tris isopropyl chlorine. This tris isopropyl chlorine is used for the this is the preservation of the new article. This is the nitrogen nitrate product. This is not stable too much. Whenever you can doing this this thing, and then immediately it can be goes out. So 12 this beta position, beta nitro position for this tris isopropyl silyl chloride is the very good reagent for the preparation only the this is the beta position, because generally what happens you can added the electrophilic substitution reaction at the aromatic heterocyclic, it always comes the down position, but this thing is going to the beta position. This halogenation reaction, in the case of this pyrrole halogenation reaction, whenever you can use the bromine ethanol is the polar protic solvent, then all these carbon substituted member, all the carbon substituted member are brominated. At the similar time, whenever you can doing the iodinations for this pyrrole, then we keep the iodine and acetone, and then you can getting the all type of iodinated bond. All type iodinated bond are obtained, and see all the 4 carbon atoms are hydrogen replaced with the iodine, and this process is called the iodination. It is happen whenever you can use the polar protic solvent. In this case of this any kind of the polyhalogenation due to the hydroactivity after the bromination. After the bromination, the reactivity of this product is greater than the starting material, and that is why the product will be participated. The product will be participated for the aromatic substitution reaction, and we getting the for the how to reduce the polyhalogenated product. The production reduction is done by the if we doing the a Bock substitution at the nitrogen group, so it can be reduce the electron density on the nitrogen group, and whenever the electron density of the nitrogen group reduces, it can reduces the flow of electron into this 5-member ring, and it is as a result the reactivity order is decreases, and that's why polyhalogenated product will be reduced. Otherwise there have been very much polyhalogenated product, but here whenever you can and substitute the nitrogen proton by this any kind of electron withdrawing group like that Bock and other thing, then what happens? Then the product formation is decreases, and we are not getting the polyhalogenated product. So to remove this polyhalogenated product, first of all can substitute the N-silyl compound, substituted with this any kind of electron withdrawing group at the nitrogen position. By the NBS, it is can obtain the 1 bromine, and whenever 2 type of bromine, that is obtain the 2 bromine at the 3 and 4 position. So after that, whenever the furan is treated with the bromine methanol, we are getting the a saturated compound where the this saturated compound is the acetal type compound, and whenever we can use the bromine in the DMF or DMSO, then the 4th substituted tri-substituted bromine in the furan is obtained. Tri-substituted furan in option. But what happened whenever we can treat this furan with the bromine methanol at 10 degrees Celsius, then that can be forming, and this OH, both the OH group ONE and O group joined at the same carbon. So it is it has a different mechanism. The mechanism is the first bromine is added up into this furan ring or pyrrole ring, and after that this furan ring will be breaking down by the substitution reaction of this nucleophile. So this type of reaction is known as a nucleophilic substitution reaction. This is known as an nucleophilic substitution reactions. And the second one, some important conversion for this heterocyclic compound furan. So first of all, whenever you can found the acetal type compound, so at this acetal as the almost very unstable under the acidic condition, whenever you can contain acetal like that hemiacetal or acetal type compound, then what happens? Then it is very much difficult to control the reaction rate. It is easily polyhalogenated, and after the halogenation product, we are just substitute the other solvent properties like ethanol, and there are an ethanol molecule. So it is, as a result, it can obtain different aliphatic substitution product. This aliphatic substituted product will be CHO, C double bond O. So it is an cis butanediol, and it is very unstable. This cis butanediol is very unstable due to the presence of the two aldehyde group. So whenever this acetyl compound can be reacted with the hydrogen and raninickel, then what happens? Then unsaturated double bond or pi bond is present in this molecule will be reduced to the single bond. There is also another procedure where this THF is there, and THF tetrahydrofuran or this is given there, and there are also dimethyl dioxazine, and then dioxazine is reacted with this thiopine, and then what happens? This phosphorus trichloride alkyl group is substituted with this CH3 CHO and this CH2O CHO. So similarly, whenever you can reduce this double bond with this leakyl hydrogen, then immediately this reaction is gone through the saturated compound, and this is a very much important transformation for the furan. Whenever the furan is started to react with the furan, dimethyl dioxazine furan, and then the reaction will be obtained. And now I'm going to do some aromatic, under the aromatic electrophilic substitution. There are some chain reaction. First of all, Vilsmeier-Hack reaction, Vilsmeier reaction. We have also this furan substituted furan. Vilsmeier reaction is the furan. There is the PCl3 and H2O under the DMF. Under the DMF, PCl3 and H2O, that can be immediately source of the formyl group. This is the source of formyl group, and this formyl group is substituted at the ortho position with respect to any heteroatom like nitrogen, oxygen, and sulfur. Nitrogen, oxygen, and sulfur, it can be halogenated at the alpha position. This reaction is Vilsmeier reaction, present by the mechanistically, and it form the imine complex. It is from the imine complex. This imine compound will be chloroimine compound. This chloroimine compound will be reacted at the ortho position of this any kind of heterocyclic compound. It is when reacted with the ortho position, and after the just diode hydrolysis. Here is some important conversion. Is the pyrrole is there, and the pyrrole is converted into this secondary amine at the alpha position. Whenever this pyridine is substituted first with the DMF and PCl3 on water, is the first position is the acetyl at the position, and then oxidation or reduction is the oxidation or reduction process is the occur. Whenever the reduction is occur, then it is very this is reduction is occurred. This is give the benzene ring. This is give the pyrrole ring, and with this pyrrole ring ortho position contain the CH2OH. And there is also another oxidation process. They what happen, this OH group going to be this carboxylic acid group. There is another example whenever you can formaldehyde, and this the secondary amine condition, and it can form the one carbon increase with this amine. This is the Manich. This is reaction is the Manich reaction. The mechanism for the Manich reaction is that first of all, nitrogen lone pair is attacked there, and after the additions there were no charge because this molecule is neutral. It already contains two things, and after that DMF react with this NN dimethyl react with this aldehyde. It can form imine complex. It will be reacted with the this 5-member heterocyclic ring, and it can be form the 5 different zone. And there are metallations. We already mentioned that 5-member rings are very much formed towards the metallation reactions. Metallation reaction is done with the chlorine or any kind of other halogenation reaction. So when lithiation of the benzene is carried out by the lithium halogen exchange, and a method that worked well for this heterocyclic too. And for the heterocyclic of this direct ortholithiations, this direct ortholithiation case, whenever the furan is added with the n-butyl lithium with heat, then what happens? Then just the one of this will be substituted at the orthoproton, and it form the ortholithiated furan. And similarly, there have been another step for this lithiation, and that can be from this 2 and 2,6 position. 2,6 position if 2,6 position, it gives the different lithiated product. And the case of the pyrrole have two type of lithiations: nitrogenous proton, and another is the carbon proton. So now this is the rule for the condition. The more ionic the metal, means nitrogen bonded, and or the better the solvating power of the solvent, and then the result is the greater is the percentage of the attack at the nitrogen atom. Similarly, whenever you can have this pyrrole compound, and we can add this pyrrole compound into Diels-Alder. This is the Gigner reagent, this phenyl magnesium bromide, and this is the potassium. So then C is the C would be the first one is the phenyl substituted pyrrole, and second one is the potassium substituted hydrogen, potassium substituted hydrogen. And after that, both the cases, this is the barium intermediate, this is a different intermediate, and this different intermediate is react with the PHCH2OH and PHCH2OH, and then what happened? This reaction will be done with the this previous one, Pilsner and Manich type of reaction. And there have another this answer for this reaction. First of all, this inertia, this pH, MdBr, and potassium are substituted the proton of this nitrogen atom, and can be replaced this position. And as a result, what happened? This as a result, what happened? This phenyl group, this alkyl group, PHCH2 CH2Cl, can add it on the nitrogen. So I already mentioned, whenever you can use the covalent, then CH2 PHCH2CH bond is bonded to this carbon. Whenever it is the sp hybridized, then the more rooted carbon will be the participant for this reaction. Now, different metallation type of reaction for the 5-member ring. In the 5-member thiophenyl ring, there if we have an n-butyl lithium, and this reacted with this compound and can abstract the proton under the lithiation, and after the carbon dioxide is added and acidified of this reaction is dying. So immediately what happened? Immediately carboxylic acid, whenever you can use the carboxylic acid, there is the ketene, and then there have been carboxylated furan. There have been another type of reaction of this furan. This is the Diels-Alder reaction. This is the Photocatalyst reaction, and Diels-Alder reaction is like that. Whenever that alkene is reacted with the action will be the reacted furan will be the reacted with the this is the NBS, and this ether at the room temperature. Then what happened? Then this is combined, and it can form a Diels-Alder reaction. This red 2-1 is the bond formed during the Diels-Alder reaction. The reaction of this pyrrole, whenever the pyrrole is reaction with the furan ring, and then immediately it can be reacted with the with this pyrrole and this anhydride, malic anhydride. There will be no reaction of this occur. And this there are ester for this furan ring. There will no ester formation. There what happened? Two rings are they are bonded, and they form the different type of compound, which is the different price. there is the furan for this the furan. Whenever you can Diels-Alder reaction, we all knows that in the Diels-Alder reaction we need two type of thing. One is the diene, another is the dienophile. So diene is that furan diene because this contain the 2 pi bond, and is the dienophile, that is the content single double bond with this carbonyl bond, and this also participated in the conversion of the this Diels-Alder reaction, and it can form the phthalic acid. This is can form the phthalic acid. Similar, if we have asked for this type of question, where does benzene and F bromine and fluorine is there, substituted as the benzene, and whenever the pyrrole is reacted with this under the magnesium TJ, that what happened, and then this first of all it can be participated to the benzene intermediate, where bromine and fluorine can be left from this molecule, and it is the benzene intermediate, and this benzene intermediate then very much prone towards the electrophilic substitution, and it can participate for the electrophilic substitution of the pyrrole ring, and it can form a Diels-Alder product. And there are an exceptional, we already mentioned that pyrrole compound never participated in the Diels-Alder reaction because the electron density are not enough for this conjugation. That's why these 5-member ring are not participated here. But if we doing this N-Bog is substituted. N-Bog is substituted the nitrogen. As a result, the result is the less. Then what happened? This more substituted double bond will be paper. More substituted double bond will be the paper, and as a result, whenever you can we can substitute the Bog or sulfonamide into this into the central atom. Then what happened? Nitrogen central atom. Then what happened? This compound, after the complication of this this reaction, then what happened? This can be participated in the another reaction. And there have been another reaction with the carbene with reaction with the this furan or pyrrole type of compound. The carbenes are the very much active. Some of this carbene is the singlet, and some of this carbene is the triplet. So depending on this behavior, triplet is always less stable than the singlet. And whenever the pyrrole is the substituted with this with the CHCl3 dichloromethane, and then what happened? Then there have been two type of reaction. First is that ring migration thing is occur, and it can form a say cyclic 3-member compound. It can form a cyclic 3-member compound, and this cyclic 3-member compound can ring open through this bond breaking, and it can form 3-chloropyridine. So whenever the pyridine is treated with the this CCl2, which is the CCl2 is the dichlorocarbene. Whenever it can it can be participated in the dichlorocarbene, then it can be from the immediately from the different type of program. And as a result, what happened? Nitrogen lone pair is participated into this lone pair, and it is immediately open up the thing which is already blocked. So this type of reaction, and similarly this nitrogen containing ester molecule, whenever you consider the nitrogen containing ester molecule, that also different reactions come into this body. So now the N-methyl pyrrole. This N-methyl pyrrole is reacted with the substituted copper bonds and the other things, and then what happened? This is give the Manage type reaction. This is also from the carbene, which is a stable carbene, because previous one the carbene does not have the any kind of stabilization, but in this carbene this has the stabilization through the ester molecule, ester molecule, and this carbene will going to this not to be first from the cyclic ring, and after the ring opening, and it can be transformed to the 5-member ring. But here what happened? Here the carbene ring is generated when this the ester methyl group is substituted the carbene molecule, and then what happened? Then the reaction will be proceeding this through. So first of all, the CHCOONE, and this is from a 3-member ring, and after the formation of the 3-member ring, there have been very after the giving the all the details into the verification table, and whatever the 3-member compound will be not formed, and whenever the 3-member compound will be not formed, then it immediately break down through either any one double bond and double single bonded 3-member ring, and as a result, what happened? As a result, this CH3, CH2, and CH2 type of subsaturated hydrocarbon thing is liquid, which can be protonated, and from the CH2, this is the CH2COOMe. And after the formation of this different type of two substrate, one should be major, another should be the minor. So there were no things whenever it is analytical, whenever it is that cleavage occur to this CH3 groups, and there have also another 5-member ring. There is the 3-member iminium ion, and this iminium ion and 3-member ring are open up to this concentrated. This is the copper bronze couple. This is very well known name reaction, Simon-Smith reaction. Another type of it is the condensation reaction. Condensation reaction, what happens whenever this furan or pyrrole are treated with this the formaldehyde, it is can condense to this, and this is the from the formaldehyde alcohol. But whenever we have the different type of substrate, and this, then what happens, polymerization reaction is happening. The polymerization, whenever the polymerization reaction is happening, after the polymerization reaction, what happens, it can form a 6-member cyclic structure. 6-member cyclic structure, and this 6-member type cyclic structure is the macrocyclic. It is well known that's a macrocyclic. Whenever macrocyclic is doing this type of polymerization, then what happens, each of these orthoposition of this each of these orthopositions for these compounds are connected to this orthoposition, and after the addition of these reactions, they can form a macrocyclic ring. They can form a macrocyclic ring. This macrocyclic ring is very important to make the porous compound, and this thing is doing by the geminal methyl groups. Whenever the carbon halogen atom are attached to the two similar carbon, that is known as a diol, and similarly, whenever the carbon compound is sufficiently lower electronegativity than nitrogen or that, so whenever that compound are mixed with this compound, then that will make this thing is more hardened than the starting material. So this is the porphyrin type of compound. Whenever the pyrrole ring is substituted with the benzene compound, and this is the pyrrole type of compound. And this is the one type of reaction for transformation like that. You have the fural alcohol aldehyde, and whenever you can participate for this reaction, then what happen? Two type of things happen. One thing is that first the protonation is occur. After the protonation, SOCl2 is reacted with this, and after the sodium cyanide is reacted, and it can after the hydrolysis reaction is happening. Before that, hydrolysis reaction is not the hydrolysis reaction for this substitute is not done. So first of all, mechanism for A to B, that is the substitute reaction to this is the one carbon bond substituted hexagonal bond, and whenever you can have an this is the furfuranol pH CH2 OH furfuranol, and then what happens, this reaction will be the proceed and the reaction will go. Then what happens, this CH2 group will be the protonated. This CH2 group will be the protonated by the proton, and this CH3 this goal, what is the goal is that our goal is that to substitute at the ortho position, and this ortho position is substituted by the CH2H group, and whenever the CH2H group where proton is there, and this protonated form can deprotonate the water molecule, and after that hydrolysis thing of this 5-member ring, it can be formed the thing. There were two type of conversion. One is the methyl chloride is there with the electrophilic carbon. Another carbon is there, that is the aromatic ring, methyl aromatic ring. But both the carbon ring are substituted. Both the carbon ring are substituted by the electrophile, but more electrophilic center at the CH2Cl. So that's why whenever you can use the sodium cyanide under the aqueous medium, the cyanide will be attacked at the ring carbon, because this ring carbon because the sodium cyanide, in the case of the sodium cyanide, solvated by the both solvent. This is aqueous solvent is there when it's solvated both the cation as well as anion, but the cyanide ion acts as a soft nucleophile. The cyanide minus ion acts as a softer nucleophile, and that can be reacted at the positions of this ring carbon, and as a result, nucleophilic substitution reaction occur. One should be occur at the ring, another should be occur at the position of this outside position of this ring, and that's why always the two things is that whenever you can change this reaction medium under the not the aqueous condition, then the product will be changes. Then what happened first is the protonation is occur, and after the protonation, what happened after the protonation, another DFF condition that can be formed the ionic form, and then ionic, whenever the ionic form is there, and we can easily the cyanide minus can attack at the two position under the CH2 position, another the C double bond C oxygen position, but it can easily attack at the CH2 position. So here the cyanide minus anion get the solvated by the both solvent, and cyanide minus act harder nucleophile. Reaction proceed through the SN1 reaction. This reaction will be proceed to this SN1 reaction, and reaction proceeds through the ion pair mechanism. This is the ion pair mechanism. So it is one problem. You can try yourself. And there have another reaction. This reaction is very important. Whenever the ketone analogous of this pyridine ring is treated with the ammonium and ammonium chloride under the ethanol in the selective heating. Why this selective heating is occur? Selective heating is occur because the obtained gas also be present in this reaction medium and act as an active reagent for this reaction. That's why whenever this ketone analogous of the pyridine is treated with the ammonia and ammonium chloride, then immediately it can be react. Ammonia is reacted at the harder center. This is the harder center, and it can form this intermediate, and after this intermediate, it can be rearranged to break the molecule, and after that, it immediately come back to this reacted with the NH2 and carbonyl molecule, and it form the this pyridine. Under the ortho position is methyl group, and the first position is the OH group. And there another thing, the ring junction with the conditions required to ring opening. So we already mentioned that whenever the pyridine compound is treated with the Lewis acid, whenever the treated with the pyridine compound with the Lewis acid, it can be break the bonded, all the bonded, and can form the glycol type of compound. But whenever this pyrrole type of compound is reacted with this hydroxylamine hydrochloride in ethanol, and the sodium then sodium carbonate reflux, they immediately form immediately forming the compound is the carbon double bond NH. This is the dioxin type of compound, and ring opening happen. So this ring opening is doing with this the different type of substrate. First of all, the this hydroxylamine and ethanol, and this under the sodium carbonate, it is can be reacted, but it can be open up their pi bonded. And there have been six. Now we're going to discuss the 6-member heterocyclic, that is the pyridine. The 6-member heterocyclic compounds are less reactive. It is very less reactive than the 5-member ring. So nitrogen atom in this pyridine ring is a planar and trigonal with the lone pair of this plane, and thus this makes it is an imine compound, and most of these imine haven't been unstable intermediate, but the pyridine is a stable imine because of this aromaticity. The p orbital of the aromatic centene are superficially at the same of this benzene, and as a result they can easily come this one. Now here is the pyridine, and pyridine is showing the mechanism, and in the case of the pyridine, there is the pK value is the 11.2, and this pyridine, it is much more, this is less than this compound. So pyridine is the accepted this this proton donations, and after that this electrophilic substitution reaction, and similarly electrophilic substitution reaction, there are two type of substitution reaction. One is the C substitution reaction, another is the N substitution reaction. So under the N substitution reaction, so whenever you can use the electrophile, C substitution is the lower energy, and the orbital of these pyridines, pyridine free systems means that the electrophile attack at the ring on the ring is very difficult. the electron density of the ring is decreased by the electron withdrawing group inductive effect and the electronegativity of the nitrogen atom. So similarly, the any substitution is happening whenever pyridine is nucleophilic and basic center at the nitrogen atom, because of the lone pair of this electron on the nitrogen could not be delocalized in the ring. So here I am showing that pyridine nucleus, in the case of the nitrogen, it does not in the plane. So the lone pair is always in the sp2 average. So it is easily round up, or it is easily round up with this pi conjugation, and this form is forming. So pyridine is bad candidate for the electrophilic aromatic substitution. So the pyridine is the very much bad candidate for the aromatic electrophilic substitution. And now they are looking to be forward for the ortho para positions in the different substitution. Resonance from the positive charge, as well as they are very unfavorable. This is unfavorable, and the beta substituted and intermediate and the transition state, leading to the more stable resonance form with the alpha. And also there is pyridine outcome, pyridinium ion. Whenever you can form the pyridinium ion, then what happens? Electrophile will be attack the nitrogen atom, and it can form the pyridinium ion. This pyridinium ion is a very less reactive. It is very much reactive towards the electrophilic substitution, because the lone pair will be moved towards this positive charge. As a result, pyridinium ion is very much reactive for this reaction. So here the regiochemical control of this reaction pronounced in this case of this pyridine ion, both pyridine and pyrimidine ion give the beta substitution product, but have slower rate than that of the benzene. Reactions will be usually proper through the small amount of this reaction. Now, in substitution will be done with the N2 plus and BF4 minus. Methyl iodide always reacted with this nitrogen atom and is formed the methylated nitrogen. And there are also sulfur trioxide. This sulfur trioxide is substituted at the nitrogen, and this from the sulfur trioxide substituted in acetyl chloride to also same substitution is occur for the nitrogen atom. There's carbon substitution in the case of the pyridine nitrations or concentrated nitric acid. So always what happens, the concentrated nitric acid and concentrated sulfuric acid produce the proton. That proton will be attacked by this proton will be this proton is be deactivated to the pyridine nucleus, deactivated to the pyridine nucleus. As a result, there are no reaction is occurred. But when the pyridine is free, the pyridine nucleus itself is free, then the reaction for this for the different kind of nitration states and other states, the product will be different. And the pyridine is the good. How this is possible? And this is what this will use the activating group and the multiple electron donating group accelerate the reaction. Multiple electron donating group are accelerated the reaction. So if you have a acetyl 1, 2, 3 for the 3 acetyl oxide, and after that concentrated nitric acid, the nitration is happening. But the halogenation reaction, we all know that there are no source of the proton, so there will be no chance to protonation for this pyridinium chloride or chloropyridinium ion. And then what happened? Then all this pyridine is good living group for the such metal, aluminium, salmonium, tin, and this once again the complex will be formed, and this complex will be this pyridinium complex will be formed, and this pyridinium complex is reacted with the different type of compound like benzyl chloride that can be doing the benzyl chloride, it can be formed a benzyl alcohol, and this pyridine is the monosubstituted. This phenyl cup acylation also similar type of reaction. And this pyridine, the aromatic nucleophilic substitution, pyridine has the two type of aromatic nucleophilic substitution. One is that directly attacked at the ipso position or the alpha or beta position, and if the alpha position is already blocked, then what happens? This nitrogen electron pair will be shifted to the another molecule. This nitrogen containing lone pairs or others compounds are situated into the different position, but otherwise what happens, they can easily manipulate the pulleys, they can easily substitute at the beta position, and this beta cup substituted product will be the nucleophilic substitution. Here different type of nucleophilic substitution is showing when this phenyl lithium, this nucleophilic reacted at the position of the where the electrophilic substitution is very much prone towards the electrophilic substitution, and as a result it can give the orthoamino pyridine. This is the hydride acceptor or oxidizing agent is required to regenerate the aromaticity. Animations occur done at the alpha positions because this type of reaction, whenever the pyridine ortho position is substituted any kind of halogen or proton, that is known as a nucleophilic substitution reaction. This is hydride transfer, and this is known as a Chichi-Papin reaction. And in the case of this Chichi-Papin reaction, alpha position is favorable because this alpha position, whenever this alpha position is participated for the nucleophilic substitution, they are generated a negative charge. This negative charge will be stabilized. This negative charge will be stabilized by the nitrogen atom. This stabilized by the nitrogen atom of the pyridine. So this is the picoline aromatic nucleophilic substitution. Why this is? Whenever the ortho position or the 2 position or the 4 position with respect to nitrogen of this ring carbon will not be free. This is substituted by the some methyl group. Then what happened? Then there have 2 options. First of all, this pyridine lone pair is conjugated with this conjugated under this condition. Then what happened? Then this under this condition, this methyl, this picoline anion is obtained. This picoline anion is stabilized through this resonance, and then what happened? Then this gamma isomer is obtained. Gamma isomer is obtained more acidic than the alpha isomer. Both are generating it with the with much more acidic than the beta isomer, and the much greater case easy of this deprotonation reaction of the alpha and gamma isomer is related to the mesomeric effect. Amination at the 3 alkyl pyridines is the reduced selectivity of the 2 position. This is the 2 position, and the alkylations of the selectivity deprotonated of the alpha methyl, whereas the amide base is produced the more stability. And here the picoline aromaticity, whenever the picoline aromaticity is the methyl group is the methyl, this methyl group will be substituted. Hydrogen chloride is used, then methyl chloride will be substituted by the CH2, and then CH2 will be attacked at the other carbon nitrogen atom, and this can be generated a nitro substituted product. And whenever this nitro product is reduces, it can easily transform to the carboxylic acid, and this carboxylic acid can be generated. And this is the carboxylate anion. This carboxylate anion will be deprotonated by the proton, and then it can be from carbocation. This carbocation, carbanion. This carbanion will be participated for this aromatic picoline aromatic substitution. And there are also 4 position. Whenever the picoline substitution reaction is occurred at the 4 position, then also similar methyl hydride can block the para position, and after that reaction will be doing with this presence of the methyl group. And this is the aromatic nucleophilic substitution of picoline reaction. Similarly, we have also different type of aromatic nucleophilic substituted and participated for the nucleophilic substitution. We get the nucleophilic substitution when this nucleophile will be substituted by the chloro, fluoro, and iodo. Then obviously iodobenzene has the fluorobenzene has the higher reactivity nucleophilic substitution because it can generate a negative charge, and which will be negatively charged, and will not be able to substitute it at the same position. Then what happened? Then if they have fluoro, bromo, and iodobenzene, then the sequence of this reaction, the sequence for the order of this reaction is the first the 4 position, but after the 2, and after that and this position. So this is the basically this is the basically nucleophilic substitution of the pyridinium or picoline complex. In this picoline complex, there is a different substitution reaction and different reagent for this reaction. And there is the pyridine in the aromatic nucleophilic substitution reaction. First of all, ring opening reaction is happen with this concentrated nitric acid and concentrated sulfuric acid, but here this NH2 group, whenever the chlorine is substituted at the position, then HCl will be removed. And then HCl is from the benzene intermediate. Then benzene intermediate is very much electrophile, and whenever we can have the proton, whenever we have the this NH benzene intermediate, this benzene intermediate will be reacted with this any kind of electrophilic center of this carbonyl carbon and other, and can be easily form this pi complex. So direct ring CH metal essence, direct CH reduced reactivity of this metal essence reaction of this pyridine, alpha position will be free, because whenever this pyridine is introduced at the alpha position, it can easily make a conjugation, which can easily make a conjugation, and lithium product will be substituted at this time. And whenever this is the example for this direct CH metal essence, the reduced selectivity is ascribed as the intermolecular delivery of butyl lithium, 2-chloro or 2-methoxy or 2-methyl thio, and the 2-dimethyl thio pyridines are lithiated efficiently at the C6 position. 3-chloro and 3-methoxy pyridines are lithiated at the 2 position, and 4-chloro and 4-methoxy amino and 4-methyl pyridines are again lithiated at the alpha carbon position. So direct lithiation when happen whenever the pyridine have a very coordinating substrate like that methoxy or any kind of coordinating ligand is there, that can immediately coordinated with the lithium and can be substituted at the ortho position of this substituted, and that is called the direct ring CH. Pyridine metal halogen exchange reaction also possible whenever the pyridine molecule also contain a halogen molecule. This halogen molecule will be ortho position. This halogen molecule will be exchanged with the other halogen molecule which contain on the other molecule. But what happened? This halogen molecule will be substituted by the alkaline anion. This alkaline anion will be substituted, and after that hydrolysis it can form the aqueous solution of this pyridine. Pyridones, you already know that pyridines are very much reactive whenever it can have the electron donating fusing group, or whenever it can have the oxygen. So it is pyridone is obtained. Pyridones have the very much similar reactivity, pyridone has a very much similarity with the pyridine molecule, because this pyridonium ions is easily stable, and it can be form is very good for substituted product. So it is the very much process for the nucleophilic substitution reaction of the pyridones. Pyridones reaction is similarly, it can be whenever the pyridones 3 position is there and this bromine water is there, then it can be formed 2 brominated product at the with respect to the ortho position of the wedge, and this that can be participated in the paraffins, that can be participated in the these nitro groups, and this can be participated for the nucleophilic pyridone nucleophilic substance. Reactions such as the halogenations, nitration, sulfation are possible. Nitrogen is a much less basic than the simple pyridines. It is not possible after that, and the substitution occur ortho or para of this oxygen substituted product. And now this is another example where Diels-Alder reaction is occur with the pyridine molecule. Diels-Alder reaction generally pyridine is giving, but other molecule is not given. But here the pyridine also, this pyridine molecule also participated in the nucleophilic substitution reactions. And this pyridones molecule, whenever the pyridine is transformed to the pyridones molecule by using the any kind of peroxide, either it is MCPPA or hydrogen peroxide. This hydrogen peroxide and MCPPA form the pyridine molecule in the pyridine N oxide, and this pyridine N oxide is a very much reactive, and then oxygen lone pair easily conjugated with this nitrogen, and it can form the stable complex of N oxide pyridinium ion. N oxide is stable in dipolar species, so it is have the more stable, and N oxide serves as a facilitator and on demand both electrophile and the nucleophile additions to be safe. Nucleophilic substitution at the alpha position and the beta position will be to be continued. And here we can show that the resonance which can be stabilized the negative charge at the 4 and 2 positions. 4 and 2 position will get the negative charge for the pyridones, and as a result this molecule is substituted at the 2 and 4 position. So here the pyridonium ions is reacted with the nitric acid and sulfuric acid. It is immediately nitronium ion is produced. This nitronium ion is reacted at the reacted at the alpha position, and this process make this process nitrations, and the chlorinations of this reaction is doing it the same way. When the first the ipso substitution product is really obtained, and when this ipso substituted product will not taking this PCl3, and then ortho position at the ortho position with respect to which group will be substituted to ortho position of this which group will be. Similar example of this pyridine N oxide with the PCl3 or PCl5 or thionyl chloride, like that, it can easily chlorinated at the alcohol substituted group. And then after the pyridine N oxide is formation, how to remove this pyridine N oxide? Basically, pyridine N oxide to pyridine is come back with using the triphenyl phosphine, and this triphenyl phosphine or methoxyphosphine can easily bond it with this oxygen atom, and it will be easily break through the negative charge on the phosphorus, and the oxygen lone pair when they're coming back. So it is phosphide. It is phosphide molecule, and this phosphide molecule can be easily be removed up, and then you can get the pyridine molecule. So first we can form the pyridine N oxide, and this pyridine N oxide can pyridine N oxide can activate this pyridine molecule for the nucleophilic and electrophilic substitution. And after the formation of this electrophilic and nucleophilic substituted product, the pyridine N oxide can be transformed to this pyridine by the triphenyl phosphine or trimethoxyphosphine type of compound. That means basically phosphorus containing molecule will be removed, this oxygen molecule. So today it is the properties for this 5-member and 6-member compound. After that, next class I will start with the synthetic strategy for the different 5-member and 6-member compound. So after that we can move to the benzo fused compound. So up to that we can study only the properties with different kind of properties for the 5-member aromatic heterocyclic and 6-member aromatic heterocyclic, how to make the pyridine into this activated molecule by the pyridine N oxide, and after that how to remove this pyridine N oxide into the pyridine. Clear? So today class up to that. Next class I will be start with the this synthesis method for the different type of heterocyclic molecule. Okay, then bye.
Okay, sir.
Sir, attendance হবে না
No, that can be contact with the Sanchita ma'am.
Okay, sir.
আচ্ছা স্যার বলছি যে নেক্সট সানডে কি ক্লাস হবে, সেটা কি কোনো মানে প্রায়র ইনফরমেশন আছে?
আমার কাছে কোনো ইনফরমেশন নেই, ওটা সঞ্চিতা ম্যাম আপনাদেরকে প্রোভাইড করবে।
আচ্ছা, আরেকটা জিনিস হচ্ছে যে এই মোটামুটি এই ফাইনাল পরীক্ষা তো অনলাইনেই হবে ধরা যাচ্ছে, তাই তো?
অলমোস্ট তাই, সেটা
মোটামুটি ওই জানো ফেব্রুয়ারি মাস নাগাদ।
হ্যাঁ।
আচ্ছা, আর থার্ড যে হচ্ছে এই যে টপিকগুলো আজকে নতুন হলো, সেটা কি ওই স্টাডি ম্যাটেরিয়ালে আছে যেটা প্রোভাইড করা হয়েছে কলেজ থেকে?
সেগুলো তো থাকবে, বাট আমি যেটা ক্লাস করাবো সেটার স্লাইড আমি সেপারেটলি তোমাদের সঙ্গে শেয়ার করব। এই যে পাওয়ার পয়েন্ট আমি পড়ালাম, এই পাওয়ার পয়েন্টটা পিডিএফ আকারে তোমাদের গ্রুপে যেটা আছে গ্রুপে আমি শেয়ার করে দেবো।
থ্যাংক ইউ। ঠিক আছে। আচ্ছা, কোনো অসুবিধা হলে মানে জিজ্ঞেস করা যদি? অবভিয়াসলি, নো প্রবলেম। ঠিক আছে, থ্যাংক ইউ।
Thank you, sir.